Yo, what's up everyone? This is LeetCode 981, time-based key value store. So we have to design a time-based key value data structure that can store multiple values for the same key at different timestamps and retrieve the key's value at a certain timestamp. Okay, so we have to implement this time map class where we initialize the object of the data structure. We have to store the key with the value at a given timestamp, and then we also have to implement this function to return it returns a value such that the set was called previously with timestamp previous being less than or equal to the timestamp that we're given. Uh, and if there are multiple such values, it returns the value associated with the largest timestamp previous. If there are no values, it returns an empty string. I know this is a little confusing, so I'm going to just go to an illustration really quick. So um, this is what it's going to look like, right? So it's almost like a hash map, except our values is kind of they're just kind of pairs, right? So this is our key, right? And we can insert a value, but when we insert the value, we also have to insert the timestamp, right? Like if you look, if we go to here, right? We set a key and then we set the value bar, but we also set the timestamp. And these two are technically values in our hash map. Like bar is the value, and then so is the timestamp, right? And there's a few things we have to discuss, right? Like what does this mean? So basically, like when we call the get function, right, we just pass in a key and a timestamp, right? So if we pass in foo, right, and this is our hash map, let's say, and let's say we're using get, right, and we pass in foo as a key, and for the timestamp, let's say we pass in a 4. Well, there is a 4, right? So we would just retrieve this, right? And this is what we would return. Well, what if we add like a 5, right? Well, there is no 5, right? So there's no value to retrieve. By the way, when we return, we're returning the actual value. That's the string, right? If you look at the get here, right, this is the return type is a string, right? So we're using this and this to basically return this. Assuming we're looking for 4, but we're looking for 5, right? But 5 doesn't exist, so what do? Because 5 doesn't exist, we have to return the most recent value. So we'd return this, okay? Because if you look down here, all the timestamps are in strictly increasing order, right? So there's a lot to this problem really to understand. I don't think the implementation is hard, but like kind of grasping this problem is a bit tricky. Okay, so yeah, we just have to implement these functions. And this class, it's not too difficult, but it is hard to process everything at once. So we're gonna go slow, okay? And I'm gonna write some comments out just so it's a little bit easier, okay? So first of all, we're gonna say note. I'm gonna say all the timestamps of the set are, or let me just copy it. I'll copy this because it's a constraint, and this will help you. Because what this is saying is basically the timestamps are linear. Time is linear, right? But the point is like you're never gonna add like a timestamp with the time 3 and then later add one with the time 2, right? That's not gonna happen, and that's not an edge case we have to handle. If that were the case, this probably be a little bit trickier, right? So we have to create our hash map, okay? So first of all, let's say self.hmap, right? And here's the set where again we have a key and we're given the key, the value, and the timestamp, and we have to basically put that into our hash map, right? Well, there's an edge case where maybe the key doesn't exist, right? In which case we have to create that in the hash map. So we're going to say if key not in self.hmap, we're going to say self.hmap key, right? And we're just going to create an empty list for the values. And down here is where we do hmap key and we append the value and the timestamp. So just to be a little bit clear what we're doing here, if we don't have this key that we're given in our hash map, we're going to create it, right? And we're just going to have an empty list. And then after that, this line is important because regardless of whether the key exists or not in the hash map, we're going to execute this line here, right? Because it's outside of the if statement. Because if the key doesn't exist, we're going to create it in the hash map, and then we'll just add the value and the timestamp here. Likewise, if the key does exist, we're not going to enter this, but we'll just add the value and the timestamp anyways, right? So yeah, not too complicated. Okay, and again, I'll try and remember to write my comments so we just know. right? We set the key, and then for the values, set the value and timestamp together. And it gets added to the end of the list, so it's O of 1, right? Because if we have something, well, what I mean by that is like if we have this already in our hash map, when we're adding this, we're just adding this to the end, right? So it's just O of 1, an O of 1 operation. So it's actually pretty efficient. Yeah, very efficient. Okay, so the get. Now this is kind of the harder one. So we're gonna say keep in mind we have a pair, right? The value and timestamp. But we are returning only the value, which is the string, right? Okay. If we don't find a match, we return an empty string. Or I should say, not if we don't have a match. We return the most value given the key. But we can return an empty value if we have nothing for that key, right? Meaning, like, let's say we had nothing here, and we're gonna say, okay, what is foo? We're gonna do get, and we're gonna pass it this key and the value 5. Well, we have nothing here, right? So we would actually return an empty string in that case. Now, the other case obviously is like if we have like a 5. Well, there is no 5 here, right? So we're gonna return the most recent one, which would be this. Okay, that's basically all it's saying. So we're going to say answer, right? And this is where we're going to return, right? The value. And so we're going to say values, and we're going to do equals self.hmap.get. We're going to say key empty list. So if no key found, return empty list. Okay, and this values is really just for the binary search that we're going to have to do, right? Now you're maybe a little bit confused as soon as I drop that on you. Why are we doing a binary search, right? Well, think about it like this. Like if we're looking for, let's say, a 4, right? Or let's say this was a really long list, right? Why would we want to do a linear scan, which is an O of n operation, when we can do a binary search, which is an O log n operation, right? So when we're looking for something, we want to reduce complexity, right? So we don't want to do a linear scan when we can avoid it. Like we can do a binary search and it'll be faster, right? That's why we're going to do a binary search. So we're really just searching for the value. Don't overcomplicate. Like, why are we using a binary search? Like, don't overcomplicate it. It's really just about reducing complexity, right? Because if you use a linear scan to find a certain value that we want to get, it's going to be O of n in worst case, whereas with binary search, it would be O log n worst case, right? So we're going to use a binary search to do this, okay? So again, remember your binary search, if you don't remember it, right? We're just going to basically set the left point and the right point and find the midpoint, right? Not too complicated. Now, I'm using Python, so I don't have to worry about overflow, but if you're using something else, remember that overflow is something you have to account for, okay? So key here, right? What we do is, we want to see if we have a match still, so we move the pointer to the right. However, this value is valid and could be the most recent, so we update the answer first. And this is where we're going to say value of m. Maybe I should call this, I'll just say mid, whatever, I don't care. We're going to say mid 1 timestamp, right? We're going to say answer is equal to value mid 0, right? We have to move the pointer, so this would be a case where we do this. And I will explain this, obviously. I'm not just writing this and then being like, yeah, see you guys. Then down here, I think we should be good. Okay. So now remember we have a pair, right? In our values for our hash map, right? These are a pair. So we have the 0th index is the actual value, which is a string, and the first index is the actual timestamp, right? So here we're basically getting the when we're doing the binary search and finding the midpoint, we're getting its timestamp and seeing if that is less than, right? the timestamp we're looking for, right? We're going to move, like, let me think how to explain this logically. Like, when we go to the midpoint, like, let's say we go here, but let's say we're looking for this timestamp. Let me change colors. Let's say we're looking for this timestamp. Well, let's say we do a binary search and we go here, right? What we're going to do basically is, okay, this does not match, or it could match or it could not, this, right? It could be, because it could be equal to, but it could be less than. So what we're going to do is we're going to take this and store it in answer, right? And then we're going to take the left pointer and move it not here, but here, so we can do the binary search and check if timestamp is somewhere over here. Because let's say we're looking for 3 or something, right? Like we're looking for 3. Well, what we're going to do is we're going to store this in answer, or technically we're storing this in answer, and then we're moving the pointer over somewhere here, right? And we're checking if we can find the 3 again. And let's say the 3 is missing, right? Well, this is already in answer, right? Because we stored it prior to moving the pointer. So in that case, even if 3 doesn't exist, we'll still return this, which is the most recent timestamp, which again, remember, if we're looking for a timestamp and that timestamp doesn't exist, we want to return the most recent one, right? So let's say we're looking for a 5. Well, 5 doesn't exist. Oh, but 4 is the most recent one, so we would return this. Okay, so that's kind of how we handle this. I hope that explanation made sense. Now, obviously, another case could be where the value that we get is not less than or equal to timestamp, but it's greater than. So like, let's say we're for some reason the midpoint is here, right? And we're actually looking for something less than that. We're just going to shift the right pointer over. Okay, so that should be it. I know this problem is a little hard to grasp your head around. Wrap your head around. It should be values, not value. Values. Yeah, don't feel too bad. I think this problem is a little. Oh, I call it M. I forgot. When I originally did this problem, I called it M. Here I'm calling it mid. But I know this problem is a tiny bit tricky to get your head around. Just because you got to think about what is our binary search exactly doing. Just remember that, like, if timestamp that we're looking for doesn't exist, the reason we're doing this line is super important, because if timestamp doesn't exist, at the very least, we're storing the value, the most recent value eventually. So even if timestamp doesn't exist, we're going to return something. And of course, guys, like if we're doing a binary search and we have an empty list, we're just going to return an empty string, right? Because if there's no timestamp, no value, no nothing, obviously we're going to return an empty string. Okay? And that says it right here. Okay? And this right here is super important, right? So always make sure you also read the constraints. They're super important. They'll always help you. Because it doesn't just tell you about your inputs. Like, it'll literally give you like very straightforward advice on like assumptions that you can make, right? But I hope this helped. Yeah, hopefully my explanation made sense with my comments and stuff. So yeah, peace out.